Have you ever wondered why you can remember yesterday, but you can't remember tomorrow? Or why a cup shatters when it falls, but the pieces never, ever just jump back together? It feels so obvious, right? But it's actually one of the deepest, most profound mysteries in all of physics. So today, we're diving into the arrow of time and trying to figure out why it only seems to point in one direction.
I mean, really think about it. You drop a cup, it shatters into 100 pieces. You could stare at that pile of ceramic for the rest of your life, for a billion years, and those pieces will never spontaneously leap back into your hand perfectly reassembled. It just doesn't happen. And that's the core of the puzzle. We see this one-way street everywhere. But here's the really weird part. The fundamental laws of physics, they don't see it at all.
And this is the paradox that has kept scientists up at night for centuries. You see, every fundamental law we know, from gravity to electromagnetism, they all work perfectly forwards and backwards in time. Seriously, if you were to watch a movie of a planet orbiting the sun and then play it in reverse, the physics would still look totally correct. The equations themselves just don't care which way time is flowing. And yet, our reality, our lives, they're completely, utterly irreversible. So what in the world is going on?
I mean, this one-way street is just baked into our very existence. We have memories of what happened yesterday, but the future? It's a total mystery. We can make choices that will change what happens tomorrow, but the past is set in stone. The crazy thing is, the individual atoms that make up you and me and that broken cup, they have no clue about this distinction. To an atom, there is no past or future. Okay, so if this arrow of time isn't hiding in the fundamental laws of physics, where on earth does it come from? Well, the first big clue to solving this whole paradox has to do with, of all things, mixing stuff up. Let's imagine a box, okay? And right down the middle, there's a divider. On one side, we've put a bunch of white gas molecules, and on the other, black ones. Now, what do you think happens when we pull that divider out? Yeah, exactly. They mix. They just start mingling, and pretty soon, the whole box is just a uniform gray mixture. This is an irreversible process, just like our poor broken cup. And here we get to the absolute key question. If you just waited and waited and waited long enough, would all those white molecules ever spontaneously decide to go back to one side and all the black molecules to the other? Now, believe it or not, the laws of physics say, yeah, technically it's possible. If every single one of those countless molecules just happened to move in exactly the right direction at the same time, it could happen. But will it?
No. The answer is just no. It's not going to happen. The sheer improbability is something we can't even wrap our heads around. It's not just unlikely. It's so fantastically, mind-bendingly unlikely that for all practical purposes, it's impossible. See, it's not a physical law stopping it. It's just pure, brutal statistics. And this is the core idea behind a concept you've probably heard of: entropy.
Right, so we often hear entropy just described as disorder or messiness, but that's a little misleading. It's really all about probability. Entropy is simply a measure of how many different ways you can arrange the little bits of a system, so that from the outside, it looks the same. For our box of gas, there are astronomically more ways for the molecules to be arranged in a mixed-up gray state than in that perfectly separated one. That's it. That's why the mixed state has higher entropy. And this brings us to the big reveal. The arrow of time doesn't come from some fundamental law of motion. It comes from the law of probability. The universe isn't being forced in one direction, it's simply moving toward whatever is overwhelmingly more likely. Think about it like shuffling a deck of cards. There's only one way for them to be in perfect, brand new order, right? But there are billions upon billions of ways for them to be all mixed up. So when you shuffle, you always go from order to disorder. Not because of some law of shuffling, but just because there are so many more disordered states for the cards to fall into. The universe works in exactly the same way.
So the past is the past because it was in a less probable, more ordered, low entropy state. And the future is the future because it's headed toward a more probable, less ordered, high entropy state. Time's arrow is just the universe naturally evolving from states with very few possible arrangements into states with vastly, vastly more. But wait, this just raises an even deeper question, doesn't it?
I mean, if the natural tendency of everything is to just become a uniform, disordered soup, why isn't it one already? Why do we see galaxies and stars and planets? Why do we see incredibly complex, ordered things like you and me? Why did the universe start out with any order to lose in the first place?
Well, the answer, as it turns out, lies at the very, very beginning of everything. You see, the order we see all around us today isn't being created out of thin air. It's being spent. It's like we're living off a cosmic inheritance we received at the birth of the universe.
For reasons we still don't totally get, the universe began in this state of incredibly low entropy, a super, super high degree of order. And ever since the Big Bang, that initial order has been unwinding, like a cosmic clock spring. Our entire history is just this process, moving from that special, ordered beginning toward a future of maximum disorder, what some people call heat death.
So here's the absolute takeaway. The Big Bang wasn't just a big explosion of stuff and energy. It was an explosion of order. And all the complexity we see in the universe today, from a star burning bright to a thought forming in your brain, is powered by the slow, steady unwinding of that initial, precious, low-entropy state. That is the ultimate source of time's arrow.
Okay, but I know what you're thinking. What about life? A tiny seed grows into a massive, complex tree. A single cell develops into an adult human. I mean, these are processes that create incredible order. Doesn't that just fly in the face of everything we've been talking about? Isn't life fighting against entropy?
Actually, not at all. Life is a perfect example of entropy in action. Here's the catch. To build order in one place, like your own body, you have to pay a kind of tax by creating even more disorder somewhere else. Think about it. You take in organized low-entropy energy, like food or sunlight, and you use it to build and maintain your complex structure. But in that process, you radiate out disorganized high-entropy waste heat. The net result? The total entropy of the universe always goes up.
And this idea just completely reframes our place in the cosmos. We're not in some epic struggle against the rising tide of chaos. We are the tide. We are a beautiful, intricate, and temporary consequence of the universe's relentless march toward disorder. I just love this line. You are not fighting entropy, you are surfing it. Life doesn't break the second law of thermodynamics, it is a magnificent expression of it. We're all just incredibly complex, entropy-increasing machines that happen to be conscious, riding this great cosmic wave as it unwinds. And just think about what that really means for a second. The order that allows you to be alive, to think, to listen to this right now, it can be traced back in an unbroken chain. Through the food you ate this morning, to the sun that grew that food, to the ancient gas cloud that formed the sun, all the way back to that initial, pristine, low-entropy state of the Big Bang. You are not just metaphorically connected to the beginning of time. You are physically part of its ongoing story. So what's the point? Why does any of this matter? Well, understanding the arrow of time isn't just some abstract physics puzzle. It fundamentally changes how we see our place in the universe, and maybe even the meaning of our own lives.
The very fact that time only moves forward is what allows for everything we care about. It allows for cause and effect. It allows for a story to unfold, for a memory to be made, for a sandcastle to be built before the tide comes in. Without increasing entropy, the universe would just be a static, boring, unchanging place. This steady journey toward disorder is what makes each moment, each change, and each experience possible at all.
You exist in this brief, unbelievably precious window of time, a moment in cosmic history balanced between the highly ordered past and the completely disordered future, a moment where the universe is still wound up enough for stars to shine, for planets to form, and for consciousness to emerge and ask these very questions. The arrow only points one way, and that's what makes every single moment matter. Isn't it something that you get to be here for this part of the ride?